The solar system, 8 planets circling a central star, our life-giving sun, once thought to be a place of order. But from time to time, the natural harmony of the heavens is disturbed when a strange light streaks across the skies, an evil star, a harbinger of doom, a comet. But the facts behind these erratic objects are far stranger than the fiction. Comets have been flying around our solar system since its creation, 4.6 billion years ago. They may have helped shape our planet's destiny. And incredibly, without them, we might not even be here.
Comets contain some of the most primitive material in the solar system, material that has been there for 4.6 billion years. It captures a record of what the solar system was like.
Comets are important for helping us to understand our place in the universe.
Comets giveth and comets taketh away. They are both the creators and the destroyers of life.
That's an astonishing claim, but there's evidence that it could be true. One thing is certain. Any object 1 mile wide crashing into Earth at over 20,000 miles an hour is going to cause major problems. We only have to look at the dinosaurs to see the devastation a comet strike can cause. 180 million years ago, dinosaurs ruled the Earth. Their reign lasted for more than 140 million years, and then suddenly, they died out. Most scientists believe their extinction was the result of a major impact 65 million years ago. A 6-mile-wide comet, or asteroid, hit Earth at over 20,000 miles per hour. The initial impact had the force of 1 trillion tons of TNT. It killed everything within an area of 300 miles. Enormous tidal waves swept around the world. The impact triggered violent earthquakes and volcanic eruptions. Savage fires swept vast distances. 1 trillion tons of debris was thrown into the atmosphere, blocking out the sun. Earth's temperature plummeted. In the blight, large herbivores and carnivores died, followed by plankton and marine reptiles. The comet's impact was devastating. It's a process that intrigues planetary scientist Carrie Liss.
Dinosaurs were dominating the planet from 120 million years ago to 65 million years ago. To put that in context, we've only been as a hint of the human race for 3 million years. Without an impact 65 million years ago, reptiles would probably still be dominating the Earth, and mammals would be secondary or just small little creatures.
The death of the dinosaurs paved the way for mammals to flourish. They were highly adaptable and soon became the dominant force on Earth. There was a sudden evolutionary boom as whole new species emerged. One of these, eventually, was us. It's 65 million years since the last mass extinction impact. Scientists believe that one day, Earth will be struck again.
We don't have to worry about that tomorrow, but in the next million years. This sounds almost like science fiction, but we do need to worry about it as a species if we don't want to have the problem the dinosaurs did.
Luckily, we have an advantage the dinosaurs never had. We're smart enough to study our enemy and uncover scientific secrets that have lain hidden since the birth of our solar system. Today, we have the technology to send fleets of satellites out into deep space to intercept comets, smash into them, even to land on them. But some of the earliest and most revolutionary research into a comet was done using a simple wooden telescope. In the 17th century, a British astronomer, Edmund Halley, tracked the movement of these celestial bodies. He correctly calculated that a comet observed in 1682 traveled around the Sun in a highly elliptical orbit, returning every 76 years. Halley's research revolutionized comet science, but he still had no idea where these mysterious bodies came from. To understand this, we will travel back in time 4.6 billion years to the very birth of our solar system. We now think that in the beginning, the solar system was just a thick molecular cloud of dust, ice, and debris spinning in space. As it spins, it collapses to form the sun. The leftover particles stick together in clumps, which in turn form comets and asteroids. Over the next 100 million years, gravity causes many of these to come together. They grow to form over 100 protoplanets. Then the most violent stage begins. A fight for survival as whole worlds collide. At the end of the war, only 8 planets remain. One of them is the embryonic Earth. Any comets that don't merge into a planet are cast out by the gravitational force of the new planets to the very outskirts of our solar system. An area billions of miles from Earth. We can't see this region directly, but by studying the orbits of thousands of comets and recording how they enter and leave inner space from every direction, scientists think comets must come from an enormous spherical cloud completely surrounding our solar system. They call it the Oort cloud.
Our best understanding of the Oort cloud is that it contains about 1 million comets, and if you're standing on one comet, your nearest neighbor would be 10 to 100 million miles away.
It's a strange existence. These bodies have floated alone through outer space for 4 billion years in orbits so vast and slow that it takes them 30 million years to circle the sun. For this reason, scientists call them long-period comets. Out here, comets are as black as coal and nothing like the bright-tailed bodies we see from Earth. But occasionally, something happens that transforms their appearance for good. Comets in the Oort cloud are unstable. The pull of a passing star can upset their equilibrium and send them plunging toward the inner solar system, accelerating as they go. For centuries, man's observation of comets was confined to ground-based telescopes. But in 1985, that all changed. The European Space Agency launched the Giotto satellite. Giotto's mission was to fly 90 million miles into space and rendezvous with Halley's Comet. Scientists hope to capture the first ever close-up color images of a comet, the nucleus rather than the tail, and unlock the secrets of its composition. Head of planetary missions at the European Space Agency is Gerhard Schwemm.
Giotto was really an exciting mission. It was also important for the European Space Agency. It was the first planetary mission, so to say. And it was really a risky mission because nobody knew about the environment of a nucleus. Would the spacecraft be destroyed?
In March 1986, Giotto flew by the nucleus at a distance of almost 400 miles, traveling at 150,000 miles an hour. Excitement grew in mission control as the first pictures of the nucleus streamed in.
It was elongated, about 10 miles long, 4 miles across, showed a lot of structure, and it also showed that the activity was really local.
This activity was gas and dust boiling off the surface of the comet. Giotto showed for the first time that gas production is confined to less than 10% of the total surface area. The rest is as black as coal. So what causes a comet to transform from an almost invisible lump into a whirling ball of bright white gas? The answer is our sun. As a comet moves closer to the sun, heat cracks the surface, and solid ice buried deep in the heart turns to gas in a process called sublimation. The cloud of gas, known as the coma, surrounds the comet. Then powerful solar winds blast the gas and dust into an enormous tail, millions of miles long. There are so few particles in it that they could all easily fit into your average suitcase and still leave room for a change of clothes. The solar wind is so strong that no matter which way a comet is traveling, the tail always flows away from the sun.
These tails can be very, very long, longer than the distance between the Earth and the sun. So a comet can be, at the same time, a very small thing, one of the smallest bodies in the solar system, and at the very same time, also a very large thing.
Throughout human history, the appearance of a comet in our skies has struck terror. People have seen them as evil omens, the bringers of death. Man's fear of comets fascinates astronomer Don Yeomans.
The fear of comets probably came from the fact that, unlike the planets, comets would appear suddenly, they would look very different from anything else in the sky, and they would disappear.
This unpredictability has even caused war. In 1066, William the Conqueror saw the appearance of Halley's Comet as a sign from God to invade the British Isles. Even in modern times, comets have resulted in very bizarre behavior.
There was the incident back in March of 1997 when Hale-Bopp, a very bright comet, appeared in the sky, and this cult, the so-called Heaven's Gate cult, thought that a spaceship was following Hale-Bopp in the skies and was meant to receive their vessels or their bodies. So 39 of them took a cocktail of phenobarbital and vodka and killed themselves.
We'll never know if the cult members' bodies made it to the mother ship. They didn't leave a forwarding address. For most of us, science has dispelled the myths surrounding comets and replaced them with a new kind of wonder. Our technology is now so powerful that we can probe these ancient bodies and through them read the entire history of our solar system. What they tell us is how the Earth first came to be. Comets are the most distant bodies in our solar system, but astonishingly, their story sheds light on our own. Comets formed in the earliest days of the solar system. They carry vital clues to the origin of our planet. To unlock the secret of a comet's composition, scientists analyze them with a spectroscope. A spectroscope works by breaking down the light given off by an object into its constituent colors. Each color is unique to a particular element. By analyzing these colors, scientists are able to infer that a comet is a dark organic compound of carbon, hydrogen, minerals, and most importantly, about 50% ice water. A dirty snowball. Now we know the recipe, Carrie Liss can build one in the lab.
These ingredients are clearly something very common found on the Earth, and yet we see them also in comets, and that's not surprising because comets made up the material that we see on Earth. So we're going to start with dry ice, which is solid carbon dioxide. This is dirt, representing the rock-forming elements we see in comets. This is water, which is about half of all the material in comets. And window cleaner, which has methanol and ammonia in it, minor icy species that we find in comets, but important ones. And finally, chocolate sauce. Chocolate is not found in comets, but it represents the complex organics. We see all kinds of amorphous carbon and PAHs and tardium-like materials. And our chocolate sauce is going to represent that because it's easy to work with. Just we'll start with the dry ice. Okay, put that in here. Dry ice is the same stuff that is used in movies in order to make fog. And you're going to see some of that come off. Oof, it's cold. Next, we're going to put in our rock-forming elements, represented by our dirt, and we're going to put a good fraction of them because they're about half of all the material we see in comets. Next, we're going to put in our complex organics, and we're going to put in a dash of them because they're only about 5 or 10%. Window cleaner. And finally, we're going to put in our water, which is the majority component, about a third to a half of all the material in comets.
With all the ingredients combined, Liss gives gravity a hand and packs them together.
Okay. And what you see here is a comet. You can see it smoking, or what looks like smoking. That's actually the carbon dioxide subliming. There's a little gas jet right there, and comets do that as well. And this is very much what we think is happening on comets. And it's even got little patches of ice. It loses about 200 pounds a second, in fact, when it comes in around the sun. And a typical comet spends a few months near the sun. This is why they're still around after 4.5 billion years, after being formed in the early solar system. They just don't spend that much time bubbling and fizzing. Most of the time they're in deep freeze.
It's incredible to think that we can deduce the composition of bodies that are millions of miles away. But we also know that from time to time, comets come close to Earth, sometimes too close. In fact, in our planet's early history, it was bombarded by billions of tons of space debris, including comets. This is called the Late Heavy Bombardment. For 200 million years, billions of tons of comets and asteroids, traveling at over 23,000 miles an hour, crashed into the Earth. The planet was a scalding cauldron of molten rock. Temperatures were almost 2,000 degrees. No life could survive in such an inhospitable place. If a person were to step onto the surface, they would instantly roast alive.
The impacts of objects coming into the Earth made the surface so hot that life couldn't possibly form, and water wasn't resident on the surface either.
So there is a mystery. Some scientists believe life began immediately after this period. But you can't have life without water. So how did water arrive on arid Earth? The answer may lie with comets. In 1985, NASA discovered water for the first time inside a comet. Hal Weaver led the investigation.
Water is necessary for life as we know it. And we know for certain that comets are predominantly composed of water, plain old water, which is a life giver, and this is one of the main ingredients of a comet nucleus.
But why didn't all the water evaporate? There is one theory. As the heavy bombardment slowed down, the Earth's temperature dropped, and molten rock on the surface began to solidify. Any later comets impacting the Earth would have ejected their water into the atmosphere. Over time, this rained back down onto the cooling Earth. Eventually, pools of water developed on the surface. But some scientists argued that not enough comets could have left the Oort cloud and found their way to Earth to provide all our water. American astronomer Gerhard Kuiper theorized that there must be another source of comets in our solar system. The area was named the Kuiper Belt, and the hunt began. For over 40 years, scientists scoured space. Then in 1992, astronomers made an amazing discovery. Beyond Neptune, in an area thought to be empty, they found the first Kuiper Belt object.
The discovery of the Kuiper Belt revolutionized our view of the solar system. No longer did the solar system end at Neptune and Pluto, but there's a whole array, a whole new region that contains, hundreds of thousands of what we're calling icy dwarf objects.
These icy dwarf objects are comets, and they are billions of miles closer to the inner solar system than those in the Oort cloud. Scientists named them short-period comets and think there are as many as 100,000 in the Kuiper Belt. Some are as large as 600 miles across. That's bigger than New York City. Calculations show that the modern-day Kuiper Belt is a shadow of its former self. The number of objects originally present was 100 times larger than it is now, making it a likely source of water-carrying comets. What is astonishing is that Kuiper Belt comets are still delivering material to the Earth today. It's no longer a bombardment, but comet dust rains down on us all the time. And this dust is key to understanding how our whole solar system formed. As our planet moves around the solar system, we sweep through the particle tails of comets. The large chunks burn up on entry into our atmosphere. Some smaller pieces float to Earth intact as space dust. This dust is fascinating to science because it contains detailed information about how the Sun, the Earth, and all the planets in our solar system formed. But there is a problem. When comet dust comes into contact with the Earth's atmosphere, it changes chemically. The record of the early solar system is damaged. Scientists began to search for a way to collect uncontaminated samples directly from a comet. NASA's Stardust mission was born. One of the chief scientists behind the project was Mike Zelensky.
To actually be able to go to a known comet and grab a sample and bring it back to Earth and have it survive all those processes was just a fantastic prospect.
The Stardust satellite's target was Comet Wild 2, a Kuiper Belt comet over 3 miles wide and traveling at over 13,000 miles an hour. To harvest the speeding dust, NASA developed a glass aerogel to catch the particles without destroying them. They mounted the aerogel inside a matrix that extended from the satellite on a tennis racket-like paddle. The mission launched in February 1999.
The day of the launch, you're out there watching this rocket and hoping that it doesn't blow up, that it takes off on time, something doesn't go wrong at the last second.
We have main engine start, 0, and liftoff of the Stardust spacecraft, returning a time capsule with the elements of the formation of our solar system.
It's just so exciting to watch it finally go, and to know that, really it's out of your hands now.
Got solid motor jettison, all 4 solids came off.
Once in orbit, the satellite began its 3 billion-mile journey to the comet. To make the rendezvous, Stardust had to orbit the Sun 3 times, then slingshot past the Earth. After 30 years in development and 5 years in flight, the moment of truth arrived as Comet Wild 2 appeared in its sights. Tension in mission control was at an all-time high.
We didn't know how close to pass to the comet. You pass too close, and the grains are so large they destroy the spacecraft. If you travel too far away, you don't catch anything.
In January 2004, Stardust flew 150 miles behind the nucleus of Comet Wild 2. The paddle extended, and a steady stream of particles smashed into the aerogel collector. With its objective complete, Stardust began the long journey home. 2 years later, the capsule carrying the dust samples broke through the Earth's atmosphere.
It's 3 in the morning, it was a very, very cold night, and we went outside and watched it re-enter. It was this huge fireball coming in.
17 degrees aft, rapid brightening.
Oh, that's cool.
NASA kept a very close eye on the capsule as it re-entered. They could not afford to lose it.
Quite a trail.
It was just tremendously exciting to watch that, to know that, there is our sample coming back, and we just go get it now, and it's ours forever.
With the capsule safely back in the lab, scientists slowly peeled the lid open. This was the moment of truth. Had the mission worked?
We looked at it, it was so clean looking, our first thought was, it didn't work. We're in trouble, we're screwed, this didn't work. And then only gradually we begin to see these impacts peppering the front of the aerogel and know that it did work.
Wow, really unbelievable. It's amazing, amazing, nice work.
At the Johnson Space Center, the job of analyzing the comet dust inside powerful electron microscopes began.
Everyone's fascinated by these crime TV shows where the scientists look carefully at tiny little clues, try to figure out who murdered this person. That's exactly what we're doing here. We're looking at tiny little clues, very carefully with giant magnifying glasses, essentially, to understand exactly how the planets were born and how the sun was born and what was there before that. And just like being a detective.
Comet detective Zelensky and his team have found grains that have been superheated. They must have formed very close to the sun in the earliest days of our solar system, and then been pushed out to the farthest reaches of space.
Here you can see the particle entered here and then crashed into here, basically expanded out, either exploded or expanded out, And grains are trapped all along this bulb surface, actually. It's incredibly exciting to be able to go into the lab and see in there, suspended in the air gel, grains that are 4.5 billion years old, and basically our distant ancestors.
The Stardust mission shows that comets aren't just remote objects hurtling through space. They are intimately bound up with Earth's own story. In fact, some scientists even argue that if it wasn't for comets, life on our planet might not exist. The Earth. It's unique in our solar system because it's covered with life. But where did the organic material that makes life possible originate? Scientists thought these vital chemicals formed in warm ponds on the planet's surface, or they were hurled out from hot springs on the seabed. But a growing band of researchers are looking at an altogether different source: space. In 2002, scientists discovered organics like simple sugars and traces of amino acids inside a molecular cloud in space. These clouds are where comets formed. Were the essential ingredients for life delivered to the Earth inside a comet? Chief planetary scientist at NASA is Mike Mumma.
The amazing thing about comets is that they could have delivered the basic chemicals necessary for the emergence of life, and they delivered them in kit form.
This is still a theory, but if a kit of organics arrived on the early Earth via a comet, then comets could have started life on Earth. One of the most important factors in the survival of these molecules is the angle the comet strikes Earth.
So if a comet comes in vertically, all of its energy is deposited quickly, and we can see this by just dropping a rock into the water. Clunk! Makes a nice big splash. The comet hits the surface at high velocity, and much of it is destroyed. But on the other hand, if the comet comes in at a shallow angle, it can actually skip in the atmosphere. And some of the energy will be deposited on each skip. And so it will slow down the comet, and more of it can then survive when the final body strikes the surface.
This photograph seems to back up Mumma's theory. Were these craters made by an object bouncing along the surface before finally coming to rest? Some scientists believe that only a small percentage of comets crashed into Earth at a shallow angle, but the bombardment was heavy enough to deliver a significant amount of organic material.
Every element in your body, carbon, nitrogen, oxygen, was formed inside a star. It later was ejected from the star, collected in an interstellar cloud, and ultimately entered into a comet. It was delivered to a growing planet in the form of water and organics, and played a role in the emergence of life. And that makes us a part of the comet, the cosmos in turn.
If the secrets of our solar system's formation and the story of the creation and evolution of life on Earth were locked inside the frozen heart of a comet, then scientists at NASA were about to find out. In 1999, NASA approved the most daring mission to a comet yet. This is the stuff of a Hollywood blockbuster. Its name, Deep Impact. The principal investigator on the mission was Micah Hearn.
Comets are a preserved record of what happened 4.5 billion years ago. Unfortunately, that record has been disturbed on the surface layers of comets, and you have to get down to the interior to understand what the data really are in the time capsule.
Deep Impact's target was Comet 9P Tempel 1, a short-period comet about 9 miles wide. The mission was to shoot a 1-ton copper probe from the spacecraft into the heart of the comet, producing a crater over 400 feet wide and 40 feet deep. Scientists hoped that the crater would reveal for the first time the pristine organic material buried deep inside the frozen nucleus of the comet.
Deep impact hitting Comet 9P Tempel 1 was quite a feat of navigation. Not only did we have to get to the comet's orbit, we had to get to the comet's orbit when the comet was there. It's like somebody on one side of the Earth shooting a bullet, and somebody on the other side of the Earth also shooting a bullet and having them hit in the middle.
In January 2005, Deep Impact blasted off from Cape Canaveral. Scientists in Mission Control waited anxiously as Deep Impact approached the comet. On July 4th, 2005, the probe hit Tempel 1 at 23,000 miles an hour. The team erupted in celebration.
I was thrilled, I was scared. 6 years of my life, if it had for any reason gone wrong, but it worked just beautifully, everything was fine, and it's a crowning achievement. It really makes you feel wonderful.
The probe's onboard camera gave scientists a ringside view of the comet right up to the moment of impact. The blast threw thousands of tons of fine dust particles into the atmosphere, much more than anyone expected. The thick cloud of dust was a real problem. It totally obscured the crater, preventing them from seeing the pristine nucleus.
The biggest disappointment was that the material came out in such fine particles that we couldn't see through it. If the material had come out with a lot of big chunks, it would have been relatively transparent.
Despite this, Deep Impact did finally reveal the consistency of a comet.
If you were standing on this body, its gravity is so weak that you'd weigh about a gram. You could easily jump off it. You could walk into orbit off of this comet. And it is so weak that you could actually burrow into it and burrow through it. It's like the strength of lemon meringue.
Modern technology has revolutionized our understanding of comets. They are no longer mystical objects of fear. They are echoes of our solar system's earliest moments. But these objects are still active today. They may even hold the key to our future. Because comets are one of the very few things that could wipe human beings from the face of the Earth. Human beings are the most successful species on the planet, and some scientists argue we owe it all to the effects of comets striking the Earth. But what may have helped create life could also wipe it out completely. Every year, the threat appears to grow as more and more comets are observed in our inner solar system.
Eventually, something is going to hit the Earth. We don't know when or how big the object is going to be, but the energy dumped into these big explosive events could wipe out, hundreds of thousands of people.
In fact, if a comet just 1 mile wide struck Earth, it would trigger a global catastrophe. The comet would rip through our atmosphere in seconds and crash at over 100,000 miles an hour. The impact would kill millions of people. But the chain reaction of natural disasters that followed would be far more devastating. Earthquakes would tear through the planet. Monster tsunamis would strike deep inland. Fire would destroy whole cities. A huge cloud of dust would obscure the sun. Weeks after the impact, the death toll would reach hundreds of millions. With little clean water or food, and our electricity network crippled, the Earth would fall into a nuclear winter. In less than a year, much of the Earth's population would be wiped out. One day, this could become a reality. Luckily, Earth has a protector, Jupiter.
Jupiter is the king of the planets. It's 320 times more massive than the Earth, and so its gravity is one of the dominant forces that interacts with comets. Jupiter just basically can swallow them up, either capture them into orbit around itself or perturb their orbit so that they really don't come directly in towards the Earth.
In 1992, we got our first glimpse of Jupiter's awesome power as it tore a comet called Shoemaker-Levy 9 into 21 pieces.
They came in at roughly 35 miles per second. This is incredibly fast. They went plunging, drilling a hole into the atmosphere of Jupiter, and then exploding. And a whole bunch of material from Jupiter then went shooting out through that same tunnel that was drilled into Jupiter's atmosphere and rained back onto Jupiter, creating these huge impact scars the size of the Earth.
The real showstopper was a 2-mile-wide fragment that struck with the energy equivalent to 6 million megatons of TNT, around 600 times the world's entire nuclear arsenal.
Witnessing an event like this really made us understand how tenuous our existence is. If we get hit, it could really threaten life as we know it.
Impact events are now rare on Earth, but they do happen. This home movie, taken in the Rockies in 1972, shows a small object bouncing along on the Earth's atmosphere before shooting back into space. If it had broken through, it could have destroyed a city. This time, we were very lucky. But the people of Tunguska, Siberia, were not so lucky. At 7:17 on the morning of June 30th, 1908, a mysterious object exploded overhead. The Earth shook with the force of an explosion equivalent to 1,000 Hiroshima bombs. The blast destroyed over 60 million trees across an area 12 times larger than Washington, D.C. Scientists now believe the blast came from either a comet or asteroid exploding 3 miles above the ground. Amazingly, only a small number of people were killed.
If a Tunguska-like event happened over a large metropolitan area instead of in the middle of Siberia, it would have caused widespread devastation.
If Jupiter fails to protect us from an extinction-level comet, is there anything we can do to protect ourselves? Don Yeomans is the manager of NASA's Near-Earth Object Program, the front line of Earth's defense.
NASA has started a near-Earth object program. They started it back in 1998 in an effort to discover and catalog and trace the motions of all the near-Earth objects that could cause global disasters should they hit.
5 observatories around the world and an army of astronomers search the skies 24 hours a day, hunting for comets and asteroids.
It's what we call a low probability, high consequence event. So while they don't happen very often, thank heavens, when they do happen, they're catastrophic. And so it makes sense to have some insurance against them.
To find them, astronomers take multiple photographs of space over a period of time. A computer then scans the images and identifies anything that moves against the background of stars. Once it finds a moving object, the team can calculate its orbit to see if it threatens Earth. If one of these bodies is on a collision course, there are a number of proposals to deal with it. One popular method is to destroy it with a massive nuclear weapon. But if this fails, it could have disastrous consequences.
If the debris is not completely pushed away from the Earth, not only do we have then the same amount of mass and energy falling on the Earth, but it's now radioactive in addition. So a very large nuclear explosion near one of these asteroids could conceivably make the problem worse, not better.
Another idea is to build a spacecraft that can intercept the comet and use powerful extendable arms to steer it into a safer orbit. Or we could attach solar sails to a comet and harness the power of the sun to gently pull it away from a collision course. In the desert of Arizona, Jay Malosh has an even more ingenious idea.
If we should find ourselves threatened by a comet, and if we know the orbit of the comet long enough ahead of time, all it takes is just a gentle push to keep it from colliding with the Earth. I'm going to demonstrate how this might be done on this object, a potato, that is about the same shape as Comet Tempel 1 or Borrelli. And I'm going to use a solar collector, this hand lens, to concentrate the desert sun onto the surface of this. In reality, we wouldn't use a lens, we'd use a mirror, but this will work out here in the desert. As I concentrate the sunlight onto my model comet, you can see that we evaporate material from the surface of the comet.
The material burning off the comet by the solar collector creates a small jet of gas. The jet produces thrust, and over time, this pushes the comet away from its collision course. Scientists are developing solar collectors, but as yet, none are big enough to push a comet away from Earth. Every year, the Near-Earth Object Program finds hundreds of new bodies. The good news is none of them pose a threat to Earth in the next century. The bad news is comets are almost impossible to spot until it's too late.
The problem with detecting a comet is that they're very black, blacker than charcoal, so they don't begin to show their cometary form until they're inside the orbit of Jupiter, well inside the orbit of Jupiter, and that's just a few months from the orbit of the Earth.
Would Earth be ready to defend itself against a planet-killing comet in just 3 months? The answer so far is no. Yet the irony is that if it hadn't been for comets, there might not be life on Earth to defend. Over the last 20 years, missions like Giotto, Stardust, and Deep Impact have increased our understanding of the solar system and our place in it. But there are still so many questions left unanswered. How did our solar system begin? And what was there before? Is the Earth unique? Or are there other planets in other solar systems that could support life? And what is the fate of the Earth and the future of mankind? Scientists at the European Space Agency hope their latest mission, Rosetta, will provide those answers. The mission takes its name from the Rosetta Stone, a tablet found by the French in Egypt that allowed historians to decipher Egyptian hieroglyphics. The satellite is halfway through its 12-year, 4.4 billion-mile journey to Comet Churyumov-Gerasimenko. When it finally arrives in 2014, it will release a small probe onto its surface. The probe will stay on the comet for a week, taking photographs and performing a chemical analysis of the ice and dust, relaying the information back to the main body of the satellite. Rosetta is now millions of miles from home in the cold, dark recesses of space. Scientists anxiously await the outcome of its mission.
It's not just flying by, it's not just observing from a distance, it's like a geologist. A geologist doesn't go out into the field and just look at a rock. He takes out a hammer and looks at the inside, see how tough it is.
There are a few experiments, once they're proposed or the idea is out there, you go, why didn't I think of that? It's simple, but once we do it, the results will be profound.
And if Rosetta can land on a comet, could we one day mine them and use their resources to propel mankind deeper and deeper into space?
If we go into space and try and build habitats, we're going to need water. Comets have water. We're going to need rocket fuel, and if you break the water down into hydrogen and oxygen, that's the most efficient type of rocket fuel. So in the future, comets may be the watering holes and fueling stations for interplanetary exploration.
One day, we may need to leave Earth and go in search of a new home, because somewhere on the edge of our solar system is a vast comet that may smash into our planet and wipe mankind off the face of the Earth.